What's up, everybody? Okay, 4 hypothesis tests, 2 days. We're gonna do this. I do this every year in class. So if we could do it in class, we could do it here online. I'm going to do one video for every one of these hypothesis tests. So I'm gonna make 4 videos right now. They're gonna be short. As you can see in my own handwriting, easy test. The next 4 tests are called non-parametric tests. We did one of them already. That was called Spearman's rank correlation. You're going to find that whenever we do anything non-parametric, it usually involves ranking things. Okay, so here we go. So each one of these non-parametric tests are counterparts to a parametric test we've done previously. This one is the parametric counterpart to the differences between 2 independent samples, either large or small samples. All right, the one we did on test number 5. The one, unfortunately, I think was the most missed question on test 5. All right, so all these words, all these doc paper words, most of the things we studied were parametric tests. Basically, what does non-parametric mean? It means this. Non-parametric tests are statistical tests not requiring assertions about parameters or about the form of underlying distributions. What the heck does that mean? It means they are simpler hypothesis tests with simpler assumptions, a lot less baggage. Okay? All right, so with that being said, let's do an example here, and I typed it up. All right, it's for 2 independent samples. Random samples of custodial salaries from New York State and Florida are as follows. At the 5% level, test the claim that the salaries of custodians are the same in both states. So here are the salaries in New York, here are the salaries in Florida. We're going to compare them. But what we are going to do in order to compare them, and this is the most important thing, we are going to rank all of the data as one big group from low to high, okay? So instead of ranking them as separate groups, you can rank them as one big group. So I'm looking, and it looks as though Florida has a lot of the low salaries, all right? New York has higher paying jobs, okay? It also costs more to live in New York. So 30,800 is the lowest number that gets the #1 rank. 24,100 is 2, 24,200 is 3, 24,300 is 4. Then there's a tie for 5th and 6th. There's 2 numbers at 24,800 here and here. They would get ranked. This is important. I hope you're paying attention. They would get ranked 5 and 6, but because they are the same numbers, they get ranked 5. You average the numbers 5 and 6, or average the ranks. So they both get ranked 5.5 and 5.5. Thus far, we have ranked 6 total numbers, though. Keep that in mind. So the next rank is going to be 7, and 25,300 gets ranked 7, and then 8, and so on and so forth. It appears that New York doesn't even come into the game until the 12th ranked number, 26,500. And then we go from there. I'm going to make a suggestion. If possible, you want to make your life easier, you could put all of the numbers, all of them, into L1. I know there was Florida and New York, but don't put them in L1 and L2. Put them all in L1. Then check this out. If you hit stat, then you go down. Notice option 2 is sort A, and then option 3 is sort D. Sort A stands for sort in ascending order. D stands for sort in descending order. So we want to sort it in ascending order. So hit enter. It asks you which list you want to do it. So you hit second, and then hit L1. So basically you're telling the calculator, sort L1 for me. Hit enter, it'll say done. So what did we just do? Hit stat and enter again. And now the data is sorted from least to greatest, Florida and New York. So there's that 23,800, which was ranked 1. So there, it's twofold why you might want to put everything in L1, but this is one thing. You could sort the data from low to high. All right, so let's go back to the notes. Ladies and gentlemen, if you can sort this data from low to high, you can do this entire hypothesis test. That's it. That's the most important part, ranking the data from low to high. All right. Scroll down. Hypotheses. In the 5th edition of this textbook, the author wrote that the means were equal. In the 10th edition of this book, he wrote that the medians are equal. I don't give a hoot what you do. You could write mean or median. I'm fine with that. So the mean or the median of New York equals the mean or the median of Florida. The salaries of the custodians are the same in both states versus they are not the same. The alpha level is 0.5. We have a familiar test statistic at Z, but we have an unfamiliar letter, capital R. What is this. Now, if this were a large sample test, we'd use Z. If this were a small sample test, which this is, we'd be using a t-test. Remember that? We'd be saying that the variances are the same and we'd have to do the pooled variance. If this were the parametric counterpart, that's what we'd have to do, the t-test. Look at these assumptions. Samples just have to be greater than 10, not 30. Okay? Independent random samples. Populations are continuous. And it says this does not mean a normal distribution. It just means something that can be measured, like ranking things. Okay? All right. So, and then I'm not saying that the populations have equal variance. They just do not differ in dispersion or shape. That means they kind of look alike. These are much more watered down than the parametric counterparts. Just got to copy that down. Here's the good news. Alpha's 0.05, and it's two-tailed, and it's a z-score. So guess what? The decision rule is super easy. Reject HO if z is greater than 1.96 or if z is less than negative 1.96. Done. Okay, the computation. What is capital R? Here is capital R. R is either the sum of the ranks of New York or the sum of the ranks of Florida. And here's the awesome thing. It doesn't matter which ranks you sum up. And by the way, you are not summing up the raw data. This is the raw data. Do not sum up the raw data. Sum up the ranks. So you're either adding up the ranks of New York or adding up the ranks of Florida. Which one's less work? New York. There's fewer numbers. So look what happened right down here. I decided, or Doc Pfeiffer decided, to add up the ranks of New York. 26 plus the 12 plus the 18. And so the sum of the ranks is 218. That's R. Done. Okay, now, this is huge. Mu sub R is this computation right here. It looks complex, it's not. It's the sample size of whichever rank you are summing up. So since we're summing up New York, this first sample size is New York. Okay, and then N1, which is New York, plus N2, which is Florida, plus 1 divided by 2. So there's 11 numbers in New York, 15 numbers in Florida, plus 1, all divided by 2. And you get 148.5. This is the big point about this. If we added the Florida ranks, then you use the sample size from Florida first. You always begin with the sample size of the list that you sum up. The rest of it is identical, N1 plus N2 plus 1, all divided by 2, but you are beginning with the ranks that you added up. I hope that makes sense. Good news, standard error, that's a sigma right there. I mean, if you can't read that, that's a sigma sub R. Is the same no matter which one you rank up. N1 times N2 times N1 plus N2 plus 1, all divided by 12. Just plug it all in, 19.27. Once you do that, the z-score is gravy. R minus mu sub R divided by sigma sub R, and you get 3.61. Guess what, folks? 3.61 is greater than 1.96, so guess what we're going to do? We're going to reject HO, and we're going to accept H1 and say that the custodial salaries in New York are different than they are in Florida. Now, if this were a parametric test after rejecting HO, we would have to make hypothesis tests. Good news, yay! No hypothesis test for this non-parametric cut. All right, if you reject, you're done. If you fail to reject, you're essentially saying that New York and Florida are the same. And so what must you do if you fail to reject? So if we fail, or not fail to reject HO, okay, that's right here. You're going to give a best point estimate, x bar sub 0. Now, to be honest, you could do this weighted mean right here. You can do that. This is where putting all the data in L1 really helps, the raw data, because now you could just do stat. You can go to calc, and you could do 1-bar stats on L1, and guess what? The X bar that's right here is the weighted average, $2,776.92. Putting all the data in L1 saves you all that time, and you don't have to do the weighted average. You could just do stat calc 1-bar stats on L1 and forget all this. All right, these theory and comments, basically, I'm just going to go through it, basically saying that the Wilcoxon rank sum test is not the only non-parametric sheriff in town. There are other non-parametric tests for this, the Mann-Whitney U test. Okay, so for one, so bottom line, you could ignore all this. Okay, there are other tests in town. We're using this test. That's it, everybody. Hope that was an easy test. It really is. Just find R and you're good, or rank the data and you're good. Bye.